Hello everyone, I'm Navneet. Thanks for the beautiful description. So here today I am going to talk about AI, and I'm assuming most of you may not be aware of some of the biggest breakthroughs in AI over the last few years. So I will highlight some of those. And before I begin, I want to share a couple of things about myself. One is, I spent several years trying to learn physics and understand the meaning of the universe and why we exist. I spent few years and then I realized maybe it is not as meaningful as trying to understand why we think, why we perceive things the way we think, and what makes us humans, what makes us alive. And that got me interested in AI. So it was 2011 when I got into AI. Basically, I switched from physics to AI. And I have been doing this for the last few years. And I have some insights that I would love to share with you guys with this presentation. So my topic is the fascinating world of machines that learn, reason, and understand just like us. So what is intelligence? These are these are the terms which get thrown about everywhere. Everyone talks about intelligence, IQ, and stuff. But not many people are aware what is intelligence in the first place. And to be honest with you, from my research, what I found, there are as many definitions of intelligence as there are people to define it. It's pretty interesting because we do not understand intelligence. The reason is very simple. We haven't made as much progress in neuroscience as we think we have, and it's going to take a couple of more decades. So what we have now is based on our limited understanding of the human brain, how the human brain works. And it's not only about human brain. If you talk about intelligence, it's injustice to talk only about humans because animals also have brain. They have intelligence in them. And surprisingly, plants also have intelligence. So even though my focus is mostly on human intelligence, but broadly speaking, there are a lot more things in the world. So the simplest definition I could come up with for intelligence is the ability to learn, reason, and understand. If you see, these are the three most important things you do every day. For any decision, when you decided to come to TED, when you decided to go for a college, when you decided to fall in love, every time you have to make a decision, these are the three major things. Learn, reason, understand. You learn from things, you understand from the world around you, and you reason about what to do, what not to do. So in the same line, I have come up with a very basic definition of AI before I get into more interesting stuff. So the definition here is artificial intelligence is the intelligence exhibited by machines or software. So I gave you the definition of intelligence. So the same thing exhibited by machines or software. Software, we can say software is nothing but a set of algorithms in our case. So I will start with examples. So the first three examples are from my own research group. And then I will also take help of some of the other work from some of the other companies to give you some of the ideas about where we are heading. So if you see this image, what do you see? You see a woman. Actually, there are three women, but basically three versions of the same woman. And it's a very complex image for a simple image recognition system. So we have built a very advanced image recognition system. When it takes this image as an input, it has to say what is there in the image. And if you start thinking now, I gave you the definition: learn and understand. So see, from this image, first we do the learning. We show lots and lots of images, show the algorithm what is what, and then it starts reasoning, and it understands from the image. So if you see the details like dupatta, if it is present or not, what is the type of the neck, what is the type of the sleeve, and stuff like that. So those things have been inferred by an algorithm. Many of us will struggle, particularly men, because we are terrible in these things. But even in case of women, if it's a rich rich set of categories, it will be difficult to identify. But an algorithm can do it this day. At least, these algorithms have been developed over the last couple of years, or maybe last 3 to 4 years, which are able to do it much better than even we human beings. Second example is this one. This is very, very interesting. because it's one of the, you could say, one of the most important problems in AI right now, image captioning. So if you see, this is the image and this is the caption. A baseball player is throwing a ball on the field. It's very fascinating. Why? Because just like we human beings do, we see the image, we infer what is going on in the image, and then we can tell the other guy what is happening. So in this project, what we did was first we taught an algorithm to see what is there, and second, describe what is there in natural language. So what you are seeing in English can also be in Telugu or Tamil or Hindi or whatever, because you can translate languages. But the idea here is you are using a natural language to describe what is there in the image. And if you think about possibilities, this could actually give vision to the blind. Because if they wear something like a wearable which they can use to walk, the wearable continuously takes the photographs from the real world and it translates into natural language, and the blind person knows how to walk, where to walk, and stuff like that. So the point I'm trying to make here is some of these basic ideas can actually have a huge impact on humanity. And it is one of the reasons we are doing some of the core research in this area. Third one is visual QA. So it is also a very good example for reasoning and understanding, because here there is a context. The question here is, what is near the tree? And the answer is clock. It's actually one of the answers. But this is the answer with highest probability. So we are showing it here. So if you see, the algorithm learned from the image, the context of the objects in the image. Where is the clock? Where is the tree? All of it. Just like we human beings do. If you can easily infer, I am standing near this screen and all, and you can ask this question and somebody can answer it because they are context aware. They understand where things are in the natural world. Moving on, like I mentioned, over the last 3-4 years, we have seen a majority of progress in AI. And if some of you are aware, the actual work in AI started in 50s. So it's more than 60 years now. But surprisingly, we got most of the success, most of the major success in AI in the last 3 to 4 years. Why? There are 2 reasons. One, we have much cheaper and much powerful computing infrastructure. And second, we have data. If you ask me where we are getting data, I can give you very easy examples. People who are taking photos here or anywhere else, you guys are going to go and put it to Facebook. So everyone is putting photographs to Facebook and other social networks, and they are keeping their photographs in their apps. So it's photographs. If you talk about location, people are sharing location every day. You asked me for location, I sent the location to you using WhatsApp yesterday. So the thing is, we are sharing data everywhere with devices, with people. All this data is very rich. It was not there. A few years ago, it was not there. Now, because of the emergence of mobile phones and Internet of Things and all these sensors, we have humongous amount of data. And this data combined with computing infrastructure has enabled the kind of innovation that was unheard of just 4 to 5 years back. So this is the actual sub-area of AI which is causing all the progress, deep learning. So what is deep learning? I will try to make it as simple as possible for you guys, because if you don't know machine learning, it's just an advanced version of machine learning. So why deep learning is interesting and why it is working so well? The reason is very simple. It is built using the same kind of hierarchical architecture that we have in our brain to understand things. Because when you see this is a clicker. When you see this, and if you have seen it multiple times, the next time I show this to you and ask you, what is this? You say clicker. But how did you learn? You learned it from the shape. First I showed you, you started seeing some corners. You started seeing some lines, some curves. And then you started seeing some of the parts of the object. And then you finally understood this should be associated with a clicker. So in a way, I can say, you learn features. Features are nothing but properties of anything, properties of an object. So you learn features in layers. So something similar is happening in deep learning. If you see, small features are learned. If you see the first box, there we have lines. small lines, small curves. In the second, you see bigger ones, because if you have seen me now and maybe a few more times, and you see me around in Bangalore, you identify me. Why? Because you have seen this part. This part is unique. You have seen this part and my hairstyle. So that could be difficult, but you will actually identify this part. That's very interesting. So you learn small things, and then you combine those things to identify the people. So this is a good example of deep learning happening in image face recognition. So I hope you got the basic idea. Deep learning is a new form of AI, and which is built on the idea of learning several features. So big neural networks and big computing infrastructures. Where are we? So I think we are at a stage where we have solved. I'm not saying we as a company, I'm saying we as human beings. We have solved some of the more standard problems in image recognition, speech, and language. And you are seeing the impact everywhere. I will give you some examples now. So this is a snapshot of Amazon. So you guys purchase stuff on Amazon or Flipkart. The interesting thing is, if you have bought a book, the next time you go there, it starts showing you similar books. So what is this? Is it AI or not? So the thing is, AI has been around you since you were born, but you didn't realize it because it was called different things at different times. It's a basic recommender system. It learned from your behavior that what kind of books you want. So based on that, it started recommending you new books. So it relates to my original definition. Second, this is, I hope some of you know about this company called Tesla, electric car company. And last year, they introduced autonomous pilot, basically autopilot mode. So what is autopilot mode? On the highway, when I was in the US last month, I saw this. So the thing is, on the highway, you can actually give entire control to the car. The car starts driving itself. So if you see this image is interesting because the first one, lower left corner, that image is more about how the car is trained and how the car understands where it is. I will tell you how it works. On the right side, you see the actual car, and in the front, you see the lady is not even touching the wheel, and it just keeps on driving. It takes the right directions. It makes all the necessary changes on the road and doesn't hit anyone. So that is autopilot. But this is semi-autopilot because there is a wheel and you can take controls. This is very interesting. This is Google's autonomous car, which was introduced last year. Why this is interesting? Because there is no steering wheel. There is no accelerator, nothing. So it's a prototype. The interesting thing about this is that it's the most sophisticated version of fully autonomous cars that we have seen, because everything is housed in the upper part. You know, that is the thing you see at the top. This is the part that is very interesting. I will tell you how it works. So if I have to explain you how autonomous cars work and why they are important and why they are going to be critical for humanity, particularly it's going to disrupt transportation. So there are three things. Every autonomous car is consisting of three parts. One is precise localization. Means when you are on the road, the car has to know where it is, corresponding to other cars around it and people. Second thing is obstacle detection. Basically, if there is something, what you have to do. If there is person crossing the road, you have to know precisely when, and you have to stop it to avoid accidents. The third thing is path planning. Like I was saying, path planning is more about how you traverse the car on the road. So these are the three fundamental ideas. So in a way, theoretically speaking, building autonomous car is very easy if you understand the fundamentals. And it is, again, based on the same definition I gave you. Learn. The car learns to drive based on actual driving on the road. You first teach it how to take turns, when, where, how to stop. The car keeps on learning. The second thing was reason and understand. So based on how we taught it, it starts reasoning when to take what decisions, and it understands the world around it. It makes use of cameras, lasers and stuff like that. So those are like, components. But what I'm trying to say here is this entire thing is actually nothing but an extension of the definition I gave you about intelligence, the basic thing. Now I'll show you a video.
You know, the first drive on public roads is something that we've been thinking about.
You can see
every
how it
moment
works.
has been building towards putting these cars on the roads where we can start learning even more from them.
When you look at the car that came out around Christmas, was the first vehicle that had kind of everything integrated and was kind of our first push through our manufacturing line. We've now been able to take that, do some reliability testing with it, and to make sure that everything really hangs together the way it's supposed to before we get them out onto the roads.
We've made the car hot, we've made the car cold, we've done durability testing, we drive it through a reliability bump track.
Getting these cars out into the public and allowing people to react to them, allowing us to see them out there, I think that's a huge deal. And most importantly, it's the necessary step to getting them to drive themselves. When we think about safety, when we think about giving people mobility, and then when you start to think longer term about the impact on cities and the ability to reclaim space and to reduce congestion and free up parking,
there is nobody in the car.
This is something where we can have a huge impact. It's exciting to see the arc of this project as it's moved to something that's starting to be realized, and then, the next step where we get to start to see people using it, and really, that'll be just fantastic.
So next thing is, like I said, where we are. Now the next thing is where we are heading. So this is also very important because this is how humanity is going to be impacted by some of the latest advances in AI. And this is called artificial general intelligence. So what is AI? What is AGI now? So whatever we have in the form of AI today is limited AI. You train it to do one thing and it does it well. If you train it to recognize people in the room, it does it well. If you train it to recognize music, it does it well. But it cannot do both the things at the same time. So you need to have a general system that works very similar to how we work. Because there is a hypothesis in the, we as human beings have developed one universal algorithm to learn things. So that is what scientists in this space are trying to build. And deep reinforcement learning is just an advanced version of deep learning, which is trying to take us closer to AGI. And how it works, it's very simple. The thing is, you as if you think about yourself, how you learn every day, you don't have to take you don't need continuous feedback. If you talk about attendance, if you talk about praise from your parents, if you talk about marks in your exams, you need some feedback to adjust yourself. You don't need continuous training. So that is where reinforcement learning comes in. So this is a very fascinating idea. I will conclude my talk with a video, but before that, this is a game that most of you have already played. This is a popular breakout game where there is a paddle, you have to move left and right, and you hit the ball hits the brick, and it disappears, and the score increases. So like I was trying to explain you guys, if the score increases, the algorithm learns it is a reward. So the input here is the screen, the output here is either move left or right or hit the ball. So this basic idea is used in building an algorithm that learns to play this game. Now the question should be, why are we spending so much effort building an algorithm that plays a simple game? The thing is, games are very, very beautiful sandbox to try out new experiments. You don't want to try it on the road with a car or a truck or a plane. You want to do it using games. Once you build the techniques, you can apply it to the real world. This is what is happening in AI, by the way. So I will conclude my talk with a very, very fascinating video about how this works. And this came out of a very interesting deep learning company from UK. And it happened 2 years back. And if you are aware, this week is very critical for AI because one of the biggest competitions in AI is going on right now in South Korea, where AlphaGo, a new algorithm by DeepMind, is fighting against one of the biggest champions in the classical game of Go, Chinese game of Go. So if that algorithm wins, it will be a milestone. So this week is going to be a part of history. So let me show you the video and conclude the talk. I just want you to pay attention, and you will see this is how we learn. The algorithm is basically trying to emulate how we are learning. It's struggling initially, but it's learning. This is the learning phase. One 20 minutes of training. You see the improvement. This is how also we learn. See this part. If you see, it's moving only when necessary. This is the most efficient version of the game. And now this is where it has already beaten human experts. And the similar ideas are being used in building other autonomous systems. Because you give a system an input from the environment, and the system starts learning it. And after the learning, it starts reasoning, understanding the environment, and it does what it is asked to. Thank you, everyone.